Hi, welcome to ToddFun.com, and today's fun is fixing a little tiny lock. That's the lock for the clock. If you've seen the previous episode, I've got a grandfather's clock made in the 1970s, and this little key sticks in there. This bolts inside the door, and then the key opens and closes it, but it just won't work. It's goofed up. So let's go to the bench and look at it and discuss fixing it and fix it, because that's what we do here. To the bench. Now, normally for a job like this, I'd break out some of this epoxy JB Weld. I use it all the time. There's a 4-minute version I use for jobs that don't have to be too strong, and then this overnight curing version. But I'm not going to do that. I'm thinking I'm going to do it differently. What's the problem with the lock? Well, this little tab sort of just goes back and forth in this, and watch the edge. When you go to move it, see how it splits right there? And then likewise on this side, as you start to move it, it opens up. And if you're really careful, you can get it to flip back and forth. But what's happening is, because it's only got a tang on this side and this side to hold this clamshell over top of this mechanism that basically just clicks back and forth, what's happening is it's torquing, and then it will get to a point where after that spreads a few times, and I have smushed it a little and crimped it and kind of cleaned it up, and yeah, it's going to fail again as soon as it goes through a few cycles, and then this just will stay permanently locked or permanently unlocked, and I don't want to risk that. So what I would probably do is, if I didn't have welding equipment, I would just spread some JB Weld on this side, and I would sort of like scratch this really good on the metal, and after cleaning it, and then put some JB Weld right in here, and then make sure that still fit inside the chamber, and then I'd repeat that over here. But because I have a welder, I'm going to try and just put a little bit of welding tack right here, and I'm going to try and use gas this time. Though a TIG welder might do it too, I just don't want to risk blowing through this with a TIG welder. I think I can do a little cleaner job with gas. Now, this is interesting that this is made in Germany. It actually, the whole clock I think is made in Germany, but it's proudly stamped right there, made in Germany. And I'd say this is the first thing I've ever had made in Germany that wasn't really good. There's no reason why they couldn't have dimpled both sides of this little clamshell and had another little tang come out on this side and down here. That would have been better engineering. And those clever Germans usually do it that way. But this one, they didn't. And there's no cost to doing that. And there's no reason why they couldn't have done that. So, at any rate, we'll correct this one mistake that they've made in Germany. Hide all my German viewers. You guys do good work, but not this one. And let's take a look at this and doing a little welding on this, and then should be good. We'll start by converting our MIG welding table into gas welding table. There, that's done. Now we just have to set up on these fire bricks. Well, maybe I didn't need the fire brick after all, in that I got her just clamped up nice and tight in this little jig using my electronics vise. And over here we have I'm just a hobby guy, and so I just Harbor Freight stuff mostly. I got Harbor Freight cart, 2 Harbor Freight regulators. This is the oxygen, this is the acetylene. I bought these 2 bottles at my local welding shop, and I paid for them outright because I don't like paying a monthly fee. And I knew that every 10 years I'll just take them in and have them replaced, and they just swap them out. I still just pay the swap fee even though I own them. That works out much better than paying a monthly fee for these small bottles. I could have gotten smaller bottles still, but when I do a project I tend to do a lot, and I don't like the small bottle kit. And then the torch kit is also Harbor Freight. Just added safety, if you want to know. I've got some backflow protection here. This prevents basically flame back from your torch through your hoses to your tanks, and I've got flame suppressors back at both of these tanks as well. So I've got output flame suppressors and torch flame suppressors. I'll link to those at in my Amazon store under, I'll make a new category called welding, I guess, because these are really safe. That way, if you're a beginner kind of hobbyist like me, if you screw something up and you hear that flame burning back through your torch, one, your torch is dead, but two, either these will stop that flame back or these will stop the flame back. And you won't, that barking noise won't scare the crap out of you so bad anymore. And these are called Western flame suppressors. If you can read it on there. Western flame arrestors. And these flame arrestors are model FA 200 for the acetylene and FA 100 for the oxygen. And I'll put the rest up at, I'll put the ones that go on the tank. You don't have to have them on the tank too, but I want them on both ends because, you know, safety for someone who's just a hobbyist. So you're not going to see the best welder in the world here, but you're going to see me doing a small welding project like I tend to do from time to time. I'm going to use a 000 torch tip. This is Victor, and that just means it has a really small orifice and it's for doing fine, almost, well, not jewelry, but really close, tiny work like this. I'll try and keep my hands out of this shot the best I can, but if I can't, I can't. Okay, I've cleaned all the surfaces really well. I brush with a clean brush and I clean everything off to boot. And I want to start with a clean welding rod. And I'm just going to carefully try and heat up the surface and then see if I can't put a little weld on that. Boy, it cherries up quick. That's pretty thin stuff, even with this little tiny tip. Okay, turn it around and do the other side. Kind of wish I had even a smaller tip than this. It's such thin stuff. Guess I could put a little right here too, huh? Dremel tool. So I tried to use the key, and my little weld's cracked right away. But it's acting like I can actually kind of see a spring inside that's not where it should be. I think there's something actually not right inside this thing. So being my little tack welds broke right away because it immediately started trying to spread, I'm gonna go ahead and take advantage of that, open it up, and see if I can't find out why it's wanting to open up so badly inside. Maybe we can fix that and then do a lot more better weld. Maybe just go really weld it really well, really get a really deep cherry red and weld it really good. I don't know if you can see those. Let me see if I can get a zoom in on that. You see where those welds broke? Yeah, maybe you can see they cracked right along that bottom. I didn't get it hot enough really. You can see where it separated. It's going to work. I just got to go a lot more aggressive with the heat. But let's open it up and see what's goofy inside. There's no reason for it to want to spread. Even that little bit of tack weld should have held it forever. There's the inside of this little lock. And the key pulls out, and it's got this little it's got this bolt that goes back and forth, and then it's got a little spring at the top with a little tang that locks on the bolt. If you take the bolt out, you can see there's a bit of a sled back there. The sled has a tang on it, a locking tang, and then that downward pushing spring. And I think what happens is this got a little jiggered up in there. Is that a real word? I don't know. So this is going to have to be cleaned up real good, soldered together, or welded together real good. And then when this goes in, if everything's lined up good, as this skeleton key turns around, it lifts on that sled first. So if I lift it, that sled pushes up the spring, and disengages the spring at the top. That sled does. And then the spring brings that tang back down and locks the bolt. The first thing the skeleton key does then is, if I can get on camera, is it goes up in that slot there, lifts on the sled, depresses the spring, lets the bolt go across the other side. I hope I got that on camera. So really, it's just I just got to make sure it's together perfectly, and then we'll weld it really deep this time. We'll really make sure we get enough heat to go deep into that metal. It's tough to do without even smaller solder or welding gear, but we'll give it another shot. So I got it back together. I've cleaned up those previous welds, and if I do squeeze it, if I have the key in there and I keep it squeezed really good, it will go back and forth. So if I can get it welded together like that, it should be a working lock again. I'll put a little grease in it before I put it in service. Okay, we're ready to try again. This Harbor Freight regulators are really hard to keep them steady at these low pressures, but I'll do my best to keep the flame just about like that, but no promises. I always wanted to have a better set of regulators, but it is what it is, I guess. I'm going to cherry it up better than I did before, so I get a deeper weld. Come on. Trying to stay out of... I'm going to get a stronger weld this time, so I'll have to grind a little off. I want to get it in there deeper this time. You don't want to be playing around with it this time. Ooh, I got a little overheated that time. Let's switch it around and do the other side now. Later. Let's get this other side just as good now. Ooh, it melted in there again. Gotta stay back a little bit, Todd. Stay back. Don't get the hole. Need to grind that off. There we go. I got it all shined up. As you can see, these welds, I would give myself about a D for these welds. As an amateur welder, I'm okay with a D, I guess. But, you know, it's really tiny work. It's really thin metal. And just, you know, I wanted to heat it up just, you know, well enough to start melting the metal, but not enough to blow through. Like I kind of just started to blow through on that corner right there. Hey, focus. I think I have another, I did a little bit on this side too. I got a little bit past the heat level on this side, but not enough to where I couldn't melt in a couple of tacks on either side, and then, you know, nothing. A good grinder can always cover up a bad welder. So there you go. But the proof in the pudding is the key goes in and it works. See, it goes left, goes right, works great, and it doesn't spread anymore. It doesn't have that spreading problem. It seems to be nice and firm. Let's go put it back in the clock, because that's the goal, you know. Get my grandfather clock to lock again. And there's the clock's final home. Nothing's in it yet, of course, because we're still fixing the mechanism. But right now it's the lock. So let's go check out the lock. And there's the lock that was not working. The door would just slop open. And on this side, we can see the repaired lock in its final home. I'm sure you could buy something like that, but you know, if I can fix it, why not, right? So let's see if it's going to work. We'll zoom in on it. And let's see. we have our skeleton key. Goes in, all in, turns all the way around, and nice and tight, just like it should be. Go back in, turn it the other way, opens right up. Then you can service the clock. Yay! Whoa, yay! Well, there you go. I fixed my lock on my old 1970s grandfather's clock. Not the cleanest job I've ever done. I wish I had a bunch of them I could practice on first and get it just the right temperature, just the right color on the metal, and then just the right rod. And well, you can't have all that when you're just trying to fix something. And it's probably going to last the rest of my life. Well, it's the welding job was good. It was deep. It was better than the just bent metal tangs that it had to kind of hold it together. So it's good. It locks really good. I wanted to kind of use the original lock because if you go out and you try and source another lock, it's going to be a little taller, a little longer, a little deeper, a little something. And the thing is, this thing's been put for and mounted for just this door. And though this one looked like it might not have been such a problem, you do run into that when you try and replace locks. And I didn't want that fuss. But we were successful in welding it, and you got to see a little bit of my welding gear. Normally I weld big stuff like car parts and mufflers and stuff, so having that little triple knot torch tip, some of those torch tips are really quality tips. They're Victor's, some of them are the Harbor Freight ones, so I kind of struggle with all the Harbor Freight stuff, and I really need to get myself some real good quality gear someday, and that way when I go to welding, most of my hassle is fighting with the gear. And I've learned that with electronics too. You know, the better your gear, the better you can do. You just can't afford it all when you're a hobbyist and a homemaker and a doer and a hacker, and you just don't have money for all that. So that's what I do. But thanks for joining. Bye.